A powerful cyclone can look like it is easing, while the danger area is actually spreading. That is the key idea behind an eyewall replacement cycle. In a mature tropical cyclone, the strongest winds usually wrap around the calm eye in a tight ring of thunderstorms called the eyewall. Sometimes a second ring of storms forms farther out from the center. For a while, the cyclone has two eyewalls, one inside the other. These are called concentric eyewalls. Between them is a quieter gap known as the moat region, where sinking air can limit cloud growth. The outer eyewall then starts competing with the inner eyewall for warm, moist air flowing into the storm. That inflow is the fuel that helps thunderstorms release heat and keep the cyclone core intense. As the outer ring becomes better organized, it intercepts more of that fuel before it reaches the inner ring. The original eyewall weakens, breaks apart, and eventually fades. The outer eyewall then becomes the new main eyewall. During this change, the peak winds close to the center often drop for a time. That can sound like good news, and sometimes it is, but it is not the same as the cyclone being over. The whole wind field can expand as the strongest ring moves outward. Think of a spinning skater. When the arms are pulled in, the spin is tight and fast. When the arms move out, the spin spreads across a wider circle. A cyclone can behave in a similar way. The highest wind speed may be lower, but damaging winds can cover more towns, roads, islands, and stretches of coastline. This matters for storm surge as well. A broader cyclone can push water toward the coast over a longer reach of shore, even if the official category is not rising. That is why coastal communities should not focus on the category number alone. Category tells you about wind speed near the center, but it does not describe the full size of the storm, the rainfall, the surge risk, or the timing of damaging winds. Forecasters look for eyewall replacement cycles using tools that can see the cyclone structure in different ways. Microwave satellite imagery can reveal rainbands and eyewalls hidden beneath high cloud. Radar becomes especially useful when a cyclone is close enough to the coast because it can show eyewalls, rain gaps, and heavy bands in near real time. The Dvorak technique also helps estimate intensity from cloud patterns, even though it cannot see every detail inside the core. For Australia, these changes matter near Queensland, the Northern Territory and Western Australia, where cyclones can approach from the Coral Sea, the Gulf of Carpentaria, or the Indian Ocean. A system may briefly weaken, then re-strengthen after the new eyewall contracts. Its track, wind extent, and impact timing can also change. The safest message is simple. If a cyclone is nearby, keep checking Bureau of Meteorology warnings and follow local emergency advice. An eyewall replacement cycle is not a sign to relax. It is a sign that the storm is reorganizing, and a reorganizing cyclone can still be dangerous across a wider area.